Welcome to Teaching IP Subnetting. This presentation is derived from the book IP Subnetting Made Easy by John Kowalski, which is available at Amazon.com. While this presentation is derived from copywritten material, free distribution is encouraged. The purpose of this video is to aid IT instructors in the teaching of the cheat sheet method found in IP Subnetting Made Easy. This presentation details only the most critical part of the book, not the entire book. Before revealing the cheat sheet method, you must teach your students what is commonly called the bit method of subnetting. This ensures that they know the basics of how network devices manipulate their network addresses. As we can see here, the cheat sheet consists of two main columns of information. The first column lists the subnet bits, used either for network or for host. The second column lists the powers of 2. The subnet bits portion can be recreated simply by numbering 1 through 8 on a piece of paper. These represent the bits used in a subnet mask for the network. The center row depicts the possible masks. If a student knows binary, this is elementary. In the case of the first line, 128 is a product of 1 network bit followed by 7 zeros. Line 2 is simply 2 network bits and 6 zeros. Line 3 consists of 3 network bits and 5 zeros, and so on. The third column represents the host bits, as these are merely the bits of a given octet that are left over from the network portion. The formula is simply 8 minus the first column. Finally, the last column is simply the powers of 2. 2 to the power of 0 through 2 to the power of 10 is shown and is usually all that is needed for most subnetting problems. Remember, before presenting this method, you should have already taught your students the concepts of binary, variable length subnet masks, and other subnetting foundation topics via either IP Subnetting Made Easy or via your own method. Let's begin with a practical example. Given a Class C address, what is the subnet mask needed to provide at least 12 hosts per subnet? Let's recreate the cheat sheet. First off, we look at the powers of 2 side and see that 16 will yield at least 12 hosts per subnet. 16 is a product of 2 to the 4th power. Since we asked for hosts, we will look over to the subnet bits portion on the host side and find a corresponding 4, as in 2 to the 4th power. Now, we know from the question that it's a Class C address, so that the mask is going to be 255.255.255.something. By using the cheat sheet, we find that that something is 240. Therefore, the answer is 255.255.255.240. Let's try another example. Given a Class C address, what is the subnet mask needed to provide at least 50 hosts per subnet? Looking at the powers of 2 on the cheat sheet, we see that 2 to the 6th will yield 64 hosts. Since we asked for hosts, we will turn again to the host side and look down the column for the number 6, as in 2 to the 6th. We know that a Class C address once again is 255.255.255.something. The cheat sheet tells us that 192 is again that something. Therefore, the answer will be 255.255.255.192. Let's try a little different question this time. Given a Class C address, what is a subnet mask needed to provide at least 20 subnets? Again, we follow the cheat sheet, look at the powers of 2, and see that 2 to the 5th will yield 32. This time, however, we will look at the network side of the cheat sheet since we asked for subnets. We find a corresponding number 5, as in 2 to the 5th, and see that a 248 mask is required. Therefore, the answer is 255.255.255.248. Here's another network question, but with a Class B address. Given a Class B address, what is the subnet mask needed to provide at least 100 networks? The powers of 2 table tells us that 2 to the 7th will fit our needs. If we look on the network side and go down to number 7, we see that a 254 mask is required. Since we know that a Class B address begins with 255.255, the answer is 255.255.254.0. Let's use the cheat sheet to try to solve a 2-part question. The question is, will a Class C address with a 27-bit mask provide at least 6 subnets with a minimum of 20 hosts per subnet? Let's look up the subnets first. 2 to the 3rd will yield 8, and the corresponding 3 will yield a 224 mask. This is a 27-bit mask. How do we know this? A Class C address is a 24-bit mask. Adding 1, 2, 3 to that equals 27. We see that we have 5 bits left over for the host. On the powers of 2 side, 2 to the 5th equals 32. Is 2 to the 3rd greater than or equal to 6? And is 2 to the 5th greater than or equal to 20? The answer in this case is yes. Here's a similar question. Will a Class C address with a 26-bit mask provide at least 3 subnets with a minimum of 70 hosts per subnet? We'll begin by looking up the subnets. 2 to the 2nd will yield 4. On the network side of the cheat sheet, we see that 2 yields a 192 mask, leaving 6 bits for host. 2 to the 6th equals 64. Is 2 to the 2nd greater than or equal to 3? And is 2 to the 6th greater than or equal to 70? The answer in this case is no. Let's try one more 2-part question. Given a Class B address, what mask is needed to yield 50 networks? How many hosts per subnet will this mask yield? 2 to the 6th will give us 64. If we look on the network side, we see that 6 corresponds to 252. So the answer to the first question is 255.255.252.0. The second part of the question, we see we have 10 bits left over. That is 8 from the 4th octet and 2 from the 3rd octet. 8 plus 2 being 10, 2 to the 10th equals 1024. As we have seen, the cheat sheet is the heart and soul of IP subnetting made easy. Why not teach it first? There are many underlying concepts that are needed to fully understand subnetting. These are covered completely in the book. This presentation only covers the cheat sheet method. IP Subnetting Made Easy was designed by an IT instructor specifically for IT students. It is inexpensive, comes in a convenient format, and is very easy to read and understand. For bulk orders for your class, contact the author at jkowalski@sc4.edu. Individual copies are available via hard copy or via Kindle at Amazon.com. Thank you for considering using IP Subnetting Made Easy as an add-on book
to your curriculum. I will leave you with some reader comments.